In my previous video, I have explained what is DTFT, the basic analysis equation and synthesis equation. In this video, we'll be studying about the properties of DTFT, which are almost similar to the properties of CTFT, which we have covered in previous videos. So, if you want to go in depth of the properties of CTFT, then that would be a building block for learning the properties of DTFT. So the properties are linearity, time shift, frequency shift, scaling property, differentiation in frequency domain, time reversal, convolution, and Parseval's theorem. And I suppose all the properties which are discussed here or which will be discussed here are same compared to the properties of CTFT. Only the difference is the fundamental equation, that is analysis equation of DTFT and CTFT are different. In CTFT you have x of j omega given by minus infinity to infinity x of t e power minus j omega t dt, and in DTFT you have x of e power j omega as summation n is equal to minus infinity to infinity x of n e power minus j omega n. Only the difference is x of j omega is replaced by x of e power j omega, integration is replaced by summation, x of t is replaced by x of n, the exponential is e power minus j omega t in case of CTFT, in case of DTFT it is e power minus j omega n. So these are the fundamental analysis equations of CTFT and DTFT. So by using this relation we have solved the different properties of CTFT. Now using this relation, that is analysis equation, we will be solving the properties of DTFT as well. So the first property is linearity property. Now we have discussed this in CTFT as well in depth. So I'll be going in brief about proving the properties of DTFT. Now we know that x of n forms DTFT pair with x of e power j omega, and y of n forms DTFT pair with the y of e power j omega. So the property of linearity says that if input is weighted sum of one or more signals, two or more signals, then output is the weighted sum of responses to individual signals. That means if I take z of n as a into x of n plus b into y of n, that is weighted sum of two signals, then output z of x of n gave x of e power j omega, so z of n will give z of e power j omega, that will be equal to a into x of e power j omega plus b into y of e power j omega. So this is what I need to prove. That means if input is weighted sum of two or more signal, weighted sum is you are multiplying by a factor, constant a and b, then the output is the weighted sum of responses to individual signals. Now let me take what is z of e power j omega is summation n is equal to minus infinity to infinity z of n e power minus j omega n. This is from the basics, because x of e power j omega is x of n e power minus j omega n. Z will become z of n. So summation n is equal to minus infinity to infinity. Z of n is a into x of n plus b into y of n into e power minus j omega n. So this will be summation n is equal to minus infinity to infinity a into x of n into e power minus j omega n. So if I split this summation, so summation n is equal to minus infinity to infinity b into y of n e power minus j omega n. So this will be equal to a into summation n is equal to minus infinity to infinity x of n e power minus j omega n plus b into summation n is equal to minus infinity to infinity y of n e power minus j omega n. So this is nothing but for discrete time Fourier transform of x of n. It is x of n into x of n into e power minus j omega n. It is x of e power j omega plus b into y of n into e power minus j omega n summation over minus infinity to plus infinity is y of e power j omega. So this will be z of e power j omega is a into x of e power j omega plus b into y of e power j omega. Now the second property is time shift property. This also I have discussed in CTFT in detail. Now I'll be solving it in brief. So we know that x of n forms a DTFT pair with x of e power j omega. Now time shift, that means what is time here? In case of CTFT it was t, here it is n, discrete time. So a shift in the input will be e power minus j omega n naught into x of e power j omega. If you compare it with CTFT, it was x of t minus t naught is equal to e power minus j omega t naught into x of j omega. So the similar property holds good for DTFT. Now if I mention this as z of n, this will be z of e power j omega. So what is z of e power j omega? It is summation n is equal to minus infinity to infinity z of n e power minus j omega n. So summation n is equal to minus infinity to infinity. Always it is a good practice to represent whatever property you need to prove by some other signal z of n. I mean, if you have a shifted version of a signal, represent it by z of n, or if you have a multiplication by exponential, then z, represent it by z of n. So what is z of n here? X of n minus n naught into e power minus j omega n. Now I will replace this n minus n naught as some other variable m. Now when n is equal to minus infinity, when n is equal to minus infinity minus n naught, minus infinity minus some small quantity n naught, so m will also tend to minus infinity. So when n is equal to plus infinity, m will tend to infinity because it is infinity minus some small quantity n naught. So the limit of the summation will not change. It will be from minus infinity to infinity, but the variable changes to m because I have substituted n minus n naught as m. So x of m e power minus j omega. So from this, what is n? N is equal to m plus n naught. So I will be getting m plus n naught. So summation m is equal to minus infinity to infinity x of m e power minus j omega m into e power minus j omega n naught. Now if you closely look here, the summation is on m, so minus e power minus j omega n naught is a constant, so e power minus j omega n naught, I can take it out. So summation m is equal to minus infinity to infinity x of m e power minus j omega n. So this function is, it is similar to x of e power j omega. What is x of e power j omega? Summation n is equal to minus infinity to infinity x of n e power minus j omega n. Here n is replaced by m, that is it. So because this DTFT representation analysis equation can be represented by any function, and I mean any variable. Here it is n, it may be m. So if it is n, the summation is on n, and here also you get n. So if it is m, x of m e power minus j omega n. So it is e power minus j omega n naught into x of e power j omega. So what is z? This is the DTFT of x of n minus n naught. That means if there is a shift in the input, there will be an exponential multiplier by that shifted version, I mean shifted value into the DTFT of x of n at the output. Now the next property is frequency shift. So I have discussed this in detail in CTFT as well. If you have time shift in the input, there will be exponential multiplier at the output. So if you multiply, now the reverse operation we are doing here, that means if you multiply an exponential at the input, you will be getting a shifted version of in the frequency. In order to prove this, if x of n forms DTFT pair with x of e power j omega, I need to find what is the DTFT of e power j omega naught into x of n DTFT. So it is x of e power j into omega minus omega naught. So this is similar to your time shift. That means if there is a time shift in the input, there will be an exponential multiplier at the output with the negative sign. Now if you multiply an exponential in the input itself, then there will be shift in the frequency. Omega is frequency in the output. Now in order to prove this, I'll assume this as z of n and this as z of e power j omega. So what is z of e power j omega? It is the DTFT of z of n. So n is equal to minus infinity to infinity z of n e power minus j omega n. So summation n is equal to minus infinity to infinity, z of n is e power j omega naught n into x of n into e power minus j omega n. All these properties are similar. In CTFT also I have solved this. So this is in DTFT, this integration in CTFT will be replaced by summation. So summation n is equal to minus infinity to infinity x of n, I will be getting e power minus j into omega minus omega naught into n. See, minus j omega n is this, minus j into minus omega, it's plus j omega naught n is this. So I have just combined these two terms. So we know that x of e power j omega is summation n is equal to minus infinity to infinity x of n e power minus j omega n. That means x of e power j omega, this omega corresponds to the omega which is present here. Now so here to the left, z of e power j omega we have. So z of e power j omega is nothing but, if you have omega here, it will be x of e power j omega. If you have omega shifted by omega minus omega naught, I will be having x of e power j into omega minus omega naught. So this is called the frequency shift property. That means this is opposite to the time shift. If you have a shift in the time, there will be exponential multiplier with the negative sign in the output, and if you multiply an exponential in the input, there will be a shift in the frequency in the output. So the next property is scaling property. If x of n forms a DTFT pair with x of e power j omega, then what is the DTFT of x of np? That is scaling by a factor p, DTFT. So this is what we need to find out. So z of n, and its DTFT is z of e power j omega. So what is z of e power j omega from the basics? It is summation n is equal to minus infinity to infinity z of n into e power minus j omega n. So it will be equal to summation n is equal to minus infinity to infinity, z of n is x of np into e power minus j omega n. Now I will substitute np as some other variable m. So when, as in the previous case, when n tends to minus infinity, m tends to minus infinity. So my m is equal to minus infinity to infinity, because when n tends to infinity, m also will tend to infinity. So x of np is m into e power minus j omega. What is n from this? N is equal to m by p. So it is m by p. Now this will be equal to summation m is equal to minus infinity to infinity x of m e power minus j omega into m by p. Sorry. Okay, if I rearrange this, summation m is equal to minus infinity to infinity x of m e power minus j omega by p into m. Now comparing this with x of e power j omega is summation n is equal to minus infinity to infinity x of n e power minus j omega n. So if omega is present, you get x of e power j omega. If omega is replaced by omega by p, so I'll be getting this as x of e power j omega by p. So this is z of e power j omega. So scaling in time domain will result in expansion in frequency domain, because omega by p is a expanded version of your spectrum of x of e power j omega. So my x of e power j omega spectrum will get expanded by a factor p. This expansion we have already seen in the very first videos, wherein if you are given with x of n and if you are asked to find x of n by 2, you get expanded version of x of n. So here also omega is replaced by omega by p, that means you get expanded version of your discrete of your DTFT spectrum. Now the fifth property is differentiation in frequency domain, which is again similar to the property which I have solved in CTFT. Now x of n forms DTFT pair with x of e power j omega. Then what is the discrete time Fourier transform of d by d omega of x of e power j omega, which will be equal to, in CTFT case it was minus jt x of t, here it will be minus jn x of n. So you can find the similarity between these. Now how do you prove this? We have x of e power j omega as summation n is equal to minus infinity to infinity x of n e power minus j omega n. Now I need to have differentiation with respect to omega in the right hand side. So dx of e power j omega divided by d omega, I'll be getting it as that means if I differentiate with respect to omega on both sides, so I need to differentiate right hand side as well. So summation n is equal to minus infinity to infinity, x of n is independent of omega, so I will be differentiating only this function d omega of e power minus j omega n. Now this will be summation n is equal to minus infinity to infinity x of n, differentiation of e power minus j omega n with respect to omega is e power minus j omega n, and differentiation is with respect to omega, so minus jn is a constant, so minus jn. So I'll be getting minus infinity to infinity minus jn x of n e power minus j omega n dx of e power j omega divided by d omega. Now if you have x of e power j omega as summation n is equal to minus infinity to infinity x of n e power minus j omega n, then we write x of n forms DTFT pair with x of e power j omega. Now in place of x of n, if you have minus j n x of n, then this will form Fourier transform, discrete time Fourier transform pair with this function. So that is what is written here. So hence minus j n x of n forms DTFT pair with d by d omega of x of e power j omega, and this property is known as frequency differentiation property, wherein you are differentiating your frequency omega, whereas in CTFT we were differentiating omega, and the property was minus jt x of t was forming Fourier transform pair with d by d omega of x of j omega. So you can compare these two. This is in case of CTFT, this is in case of DTFT. Now the next property is convolution property. So I have told the basics about convolution. That is, convolution in time domain will be equal to multiplication in frequency domain, and the same thing holds good here as well. So if you have two sequences x of n forming a DTFT pair with x of e power j omega, and y of n forming a DTFT pair with y of e power j omega. Then z of n is got by convolution of x of n and y of n, the DTFT of which is z of e power j omega. It is nothing but x of e power j omega into y of e power j omega. That means if you have convolution in time domain, in frequency domain you have multiplication. So this one, this I need to prove. Now the right hand side, x of e power j omega, it is, z of e power j omega, it is summation n is equal to minus infinity to infinity z of n e power minus j omega n. Now what is z of n? Summation n is equal to minus infinity to infinity. Z of n is x of n convolution y of n e power minus j omega n. Now from the basics of convolution, x of n convolution y of n is summation k is equal to minus infinity to infinity x of k into y of n minus k. This is the standard form of convolution sum. So what you have here is convolution sum, whereas in case of CTFT it was convolution integral. So here you have convolution sum into e power minus j omega n. Now if I take this summation outside, summation k is equal to minus infinity to infinity x of k, because I had, if you look into my proof of CTFT properties of convolution, I had taken x of tau out. So similarly here also x of k I will be taking it out. So I will be getting a summation n is equal to minus infinity, this summation will come here, infinity y of n minus k into e power minus j omega n. Now I will be substituting n minus k as some other variable m. N minus k, I will be substituting it as m. Now the limit was on n, now it will be on m with the same limits. The variable is m. And from this, what is n? N is equal to m plus k. So if I substitute it here, summation k is equal to minus infinity to infinity, x of k will remain the same. Summation m is equal to minus infinity to infinity, because n minus k is substituted as m. Y of n minus k is m into e power minus j omega into n is m plus k. So if I rearrange this, summation k is equal to minus infinity to infinity x of k, I have e power minus j omega k. So e power minus j omega k into summation m is equal to minus infinity to infinity y of m e power minus j omega m. This is m. So y of m e power minus j omega m, e power minus j omega k, I have taken it with this factor. So what is this term? It is of the form summation n is equal to minus infinity to infinity x of n e power minus j omega n. So this is DTFT of x of n, whereas here it is x of n only with the different variable k. So it is x of e power j omega into y of e power j omega. This is z of e power j omega. That means x of k e power minus j omega k is nothing but discrete time Fourier transform of x of n, where n is replaced by k, that's it. And here also it is n is replaced by m. So the convolution in time domain got converted into multiplication in frequency domain. This is multiplication, not again convolution. So it is multiplication in frequency domain. Now the next property is Parseval's theorem. We have solved this in CTFT as well. So it gives us the relationship between energy of the signal and its power spectral density. Now the Parseval's theorem in CTFT case was integral minus infinity to infinity x of t whole square dt was equal to 1 by 2 pi integral minus infinity to infinity x of j omega whole square d omega. In case of DTFT, it will be in summation, because some integral will be replaced by summation in case of discrete time signals. So summation n is equal to minus infinity to infinity x of n whole square. So as you can see this is this expression was expression of energy of the signal. Even this in discrete time domain, it is the expression for energy of the signal. So if you want to know more about energy of the signal, then please have a look into my video which deals with energy and power signals. So this would be equal to 1 by 2 pi. Now integral here was minus infinity to infinity, but here the integral is between minus pi to plus pi, because my DTFT is periodic with period 2 pi, which I have already proved in my previous video. So I'll be getting x of e power j omega whole square and d omega. Now if I want to prove this, the left hand side summation n is equal to minus infinity to infinity modulus of x of n whole square. So I can write it as minus infinity to infinity x of n into x conjugate of n, as I've done in CTFT case. Now what is x of n inverse CTFT inverse DTFT formula? 1 by 2 pi integration minus pi to pi x of e power j omega e power j omega n d omega. Now what is x star of n conjugate? So it is 1 by 2 pi minus pi to pi x conjugate of e power j omega into e power minus j omega n d omega. So if I substitute that here, summation n is equal to minus infinity to infinity x of n into 1 by 2 pi integration minus pi to pi. This I'm substituting here. So it is x conjugate of e power j omega into e power minus j omega n d omega. Now I'll take 1 by 2 pi integration minus pi to pi out, x star of e power j omega. I'll be getting summation n is equal to minus infinity to infinity x of n e power minus j omega n into d omega. This is separate. D omega is present here. I've moved my summation inside and I have taken integration outside. So it will be 1 by 2 pi integration minus pi to pi x of e power j omega with conjugation. And what is this term as a whole? It is x of e power j omega. It is DTFT of x of n. So it is x of e power j omega d omega. Now this I can write it as 1 by 2 pi integral minus pi to pi modulus of x of e power j omega whole square, because you have a conjugation, excuse me, here. So I'll be on the left hand side, it is minus infinity to infinity modulus of x of n whole square, which is equal to 1 by 2 pi minus pi to pi integration x of e power j omega whole square d omega. That means this relation in specific, Parseval's theorem for that matter, in specific deals with energy of the discrete time signal with its power spectral density. Now the last property is time reversal property. As the name says, there will be a reversal in the time in the input. If x of n forms DTFT pair with x of e power j omega, if there is a time reversal in the input x of minus n, then what is a DTFT? That is what we need to find out. So this I will take it as z of n, and this will be z of e power j omega. So what is z of e power j omega from the basics of DTFT? It is summation n is equal to minus infinity to infinity z of n e power minus j omega n. So it is summation n is equal to minus infinity to infinity z of n is x of minus n e power minus j omega n. Now if I substitute minus n as m, right? So if n is equal to minus infinity, m will be infinity. So the lower limit will be infinity, upper limit will be minus infinity, because if n is equal to infinity, minus m will be minus infinity. So x of n into e power minus j omega n is minus m. But the summation, the limits can be interchanged because it will not affect the value of the summation. Whereas in integration, if the limits of integration are changed, then the integration value will be negative. So you get summation m is equal to minus infinity to infinity x of n, sorry, n had become m, x of m into e power minus j omega into minus n. So this is, I can write it as m is equal to minus infinity to infinity x of m e power minus j into minus omega into m. So if you have x of e power j omega as summation n is equal to minus infinity to infinity x of n e power minus j omega n, this omega will be replaced here. I mean, x of e power j omega is this omega. That means if there is a shift, there will also be a shift in the DTFT of x of n. So what you have here is minus omega. So this will be equal to x of e power minus j omega. So that means if the if there is a folding or time shift in the, I mean time reversal in the input, there will be corresponding time reversal in the output as well. That means e power j omega, x of e power j omega will become x of e power minus j omega. So I've solved all the properties, or I've proved the properties under DTFT. That means I've solved 8 properties which were very similar to CTFT properties. So thank you for watching.